Welcome to Rose Project for 11 Science conducted by Yashwantrao Chavan Institute of Science, Satara. So this is the last lecture for the topic straight line. In this lecture, we will discuss the general equation of a line, then point of intersection of lines, then the distance of the origin from a line, the distance between point and a line, the distance between parallel lines, and last one, family of lines. So these are the 6 points which we are going to discuss in this lecture. So first, general equation of a line. We can put equation of every line in the form ax plus by plus c is equal to 0. So every equation can be put in this form. This form of equation of a line is called general form. The circular quadratic equations of form also ax square plus bx plus c is equal to 0. General quadratic equation. Similarly, general equation of a line ax plus by plus c is equal to 0. So every equation of a line can be put in this form. The general form of y is equal to 3x plus 2 is 3x minus y plus 2 is equal to 0. So we take y to RHS and we can write the given equation in the form of ax plus by plus c is equal to 0. The general form of x upon 2 plus y upon 3 is equal to 1. So this is double intercept form. So this can be put in the form that is 3x plus 2y minus 6 is equal to 0. Equation of the line ax plus by plus c is equal to 0. So this above equation can be written as y is equal to minus a upon b into x plus minus c upon e. So above equation can be written as y is equal to, so minus ax minus c divided both sides by b. So minus a upon b times x plus minus c upon e. Comparing above equation with y is equal to mx plus c, we get m is equal to minus a upon b and y-intercept c is minus c upon a. So we have got the slope of this line x plus by plus c is minus a upon b. So minus times coefficient of x upon coefficient of y. So if we are given the equation of a line, we can find directly slope of the line, that is minus a upon b. And its the intercepts are minus c by a, and x-intercept is minus c by a and y-intercept is minus c by b. So just putting x is equal to 0, we will get y-intercept, and put y is equal to 0, we will get x-intercept of a line. Question: show that lines x minus 2y minus 7 is equal to 0 and 2x plus y plus 1 is equal to 0 are perpendicular to each other. So we have to show that given lines are perpendicular to each other. So just we have seen how to find the slope of the given lines. So let m1 and m2 be the slopes of the lines. So m1 is equal to minus coefficient of x upon coefficient of y. So minus 1 upon minus 2, that is 1 by 2. And the slope of second line m2, 2x plus y plus 1 is equal to 0, that is minus coefficient of x minus 2 upon coefficient of y 1, so minus 2. Now m1 into m2, 1 by 2 into minus 2, that is minus 1. So therefore we know that if the product of the slopes of the lines is minus 1, then those lines are perpendicular to each other. So the given lines are perpendicular to each other. Find the acute angle between the lines y is equal to root 3x plus 1 and root 3y minus x plus 7. Solution: we have seen the formula of acute angle between the lines. इथं फक्त मी हे example घेतलेलं आहे की आपण डायरेक्ट लाईन वरून स्लोप काढणार आहे. Slopes of the given lines are m1 is equal to root 3 and m2 is equal to minus 1 upon root 3. So here m1 is root 3 minus coefficient of x upon coefficient of y. Here slope of this line is root 3 and slope of this other line, that is 1 upon root 3. So now the acute angle theta between lines having slopes m1 and m2 is given by tan theta m1 minus m2 upon 1 plus m1 into m2. Now putting the values, tan theta root 3 minus 1 upon root 3, 1 plus root 3 into 1 upon root 3. So here root 3 gets cancelled in denominator, so 1 plus 1, root 3 minus 1 upon root 3. Now 1 plus 1 here 2, and taking LCM of numerator, so 3 minus 1 upon root 3. So that is 1 minus here 3 minus 1 upon, so minus 2 upon 2. So 2 gets cancelled, minus 1 upon root 3, that is 1 upon root 3. So for this 1 upon root 3, theta must be 30 degree. So acute angle between the lines is 30 degree. Now point of intersection of two lines. How to find the point of intersection of two lines? The coordinates of the point of intersection of two intersecting lines can be obtained by solving their equations simultaneously. दिलेल्या लाईन्स इक्वेशन सायमल्टेनियसली सॉल्व्ह करून आपल्याला त्या दोन लाईन्सचं पॉइंट ऑफ इंटरसेक्शन मिळेल. Find the coordinates of the point of intersection of lines x plus 2y is equal to 3 and 2x minus y is equal to 1. Now we have seen in 10th standard how to solve these two simultaneous equations. So there are different methods. One of the method is Cramer's rule, method of elimination, method of substitution. So by using one of these three method, we can find the solution. So solving equation x plus 2y is equal to 3 and 2x minus 1, 2x minus y is equal to 1. Simultaneously, we get x equal to 1 and y is equal to 1. So this is the point of intersection of two lines. Algebraically, this is the solution of these two linear equations, and geometrically, this is the point of intersection of these two lines. Next, distance of the origin from a line. The distance of the origin from the line ax plus by plus c is equal to 0 is given by p modulus of c upon root a square plus b square. Mod of c upon root a square plus b square. Now we see the proof. Let a and b be the points where line x plus by plus c cuts the coordinate axis. So this is the figure. So this is the line which cuts x-axis at the point A and y-axis at the point B. So here x-intercept is putting y is equal to 0, x-intercept is minus c by a and y-intercept is minus c by b. So a minus c by a 0 and b 0 minus c by b. So OA, distance OA is, so this is the distance OA. Let me show you, this is the distance OA, which is c by a, and this is the distance OB, that is c by b. By Pythagoras theorem, AB square, so axes are perpendicular to each other. So by Pythagoras theorem, AB square is equal to OA square plus OB square. So AB square is equal to minus c by a bracket square plus minus c by b bracket square. So squaring c square upon a square plus c square upon b square. So c square taken out from these two terms. So here c square as it is. The c square high in our name. So c square take out common from both the terms. So c square and a square plus b square upon a square into b square. So just taking the LCM of two terms. So taking square root of both the sides, AB is equal to square root of c square is c, square root of a square b square is AB, and square root of this term a square plus b square is root a square plus b square. Now area of triangle OAB, area of triangle OAB, this is right angle triangle, and area of triangle is half times base into height, half times product of perpendicular sides, half times AB. So here area of triangle OAB is base AB into height ON, that is half. AB is, we have just calculated here, C upon AB here, C upon AB into root A square plus B square into P. But area of triangle OAB is half OA into OB. So this is the another way by which we can find the area of this triangle OAB. So half into this base OA, and this is the height OB. So in this way, half OA is, length of OA is C by A, length of OB is C by B. So from 1 and 2, so area is same, triangle is same, but we have just calculated the area in two different ways. So therefore, half mod of C upon AB, root A square plus B square into P, and half C upon A into C upon B. So this is C square upon 2AB. So here we cancel 2 from both the sides, AB from both the sides here. So this 2 from 2AB from both the sides. Again, C from both the sides. So therefore, we have left with P here, 1C is left in the numerator, C upon root A square plus B square. So this is the formula. By using this formula, we can find the distance between line and origin, that is P, C, that is constant of that line, divided by sum of squares of coefficient of X and coefficient of Y. So this is the formula which gives the distance between point and line. Now we have the example, find the distance of the origin from the line 3x plus 4y minus 15 is equal to 0. Solution, the distance of the origin from the line ax plus by plus c is equal to 0 is given by P is equal to C upon root A square plus B square. So there is mod because distance is always positive. Therefore, the distance of the origin from the line 3x plus 4y plus 15 is equal to 0 is given by P is equal to C is minus 15, and this is square root of sum of squares of coefficient of X plus coefficient of sum of squares of coefficient of X and Y. So 3 square 9, 4 square 16, 9 plus 16 25, square root of 25 is 5. So 15 upon 5 is 3. So distance of this line from the origin is 3. The distance of the point x1, y1 from the line ax plus by plus c is equal to 0. The distance of the point px1, y1 from line ax plus by plus c is equal to 0 is given by P modulus of ax1 plus by1 plus c upon root a square plus b square. So this is the formula. By using this formula, we can find the distance between given point px1, y1 and the given line ax plus by plus c is equal to 0. So this is formula. Here x and y1, x and y replaced by x1 and y1 from the equation of a line, and this is the quantity by which this divided by the quantity root a square plus b square. So proof. So consider the figure. So this is the line. This is the line which intersect x and y axis at point A and B. If line ax plus by plus c is equal to 0 cuts coordinate axis in A and B respectively, then A is minus c by A 0 and B is 0 minus c by B. Here, a given line intersect x axis at A. So how to obtain this coordinate? Put y is equal to 0, you will get x intercept of the line. So minus c by A. And then put x equal to 0, you will get the y intercept of the line minus c by B. Let P and B perpendicular to x plus by plus c is equal to 0. So this is the Pn perpendicular to this line. So P is equal to Pn, small p is equal to Pn. Area of triangle PBA. area of triangle PBA is equal to half base BA into height PN is equal to half base height is PN, that is P, and this distance AB is obtained by using distance formula root x1 minus x2 bracket square plus y1 minus y2 bracket square. So here minus C by A bracket square plus C by B minus C by B bracket square. So this is C square upon A square plus C square upon B square. So here C square taken common from each term, so half, and taking the cross product, that is A square plus B square upon 2AB, and P, C is taken common, C square comes out from the square root sign, that is C. So this is the area of triangle PBA. Now Px1 y1 B minus C by 0 and C 0 minus C 0 minus C by B are vertices of triangle PBA. So these are the vertices of the triangle PBA. So this is the point x1 y1, Px1 y1 B minus C by A 0 and C 0 minus C by B. So these are the vertices of the triangle. Now area of triangle PBA, which we have seen in determinant. So half times x1 y1 1, x1 y1 1, x2 y2 1, x3 y3 1. So here 1 1 1, x1 y1 here, then minus C by A 0, minus C by A 0, and 0 minus C by B. So if we expand this determinant, we will get half times here. We can expand this determinant 1. So here C square by AB minus 0. So this is C square by AB. X1 times, so minus C by B minus 0. So minus x1 times minus C by B minus 0. So this is x1 C by B, and y1, that is 0 minus of minus C by A. So plus C by A, y1 C by A. So this is the area of the triangle. From 1 and 2, we get, so area of triangle PBA and area of triangle PBA must be same, but we have just calculated from two different formulae. So here, so this is LHS PC root A square plus B square upon 2AB, and this is RHS half times AC. So this is just taken LCM of these three terms. So multiply, taken the LCM. आपण ह्या तिन्ही टर्मचा डिनॉमिनेटर ए बी केलेला आहे, त्यासाठी या टर्मला ए ने डिवाइड मल्टिप्लाय केलेला आहे, तर बी बी ने डिवाइड मल्टिप्लाय केलेला आहे. So denominator is same AB. Now here 2AB cancel with, so this 2AB. So one of the C cancel with this C. So P is equal to modulus of AX1 plus BY1 plus C upon this term root A square plus B square. So this is the formula by which we can find the distance between point and line. So this is the line x plus by plus is equal to 0. This is the distance d, perpendicular distance. We are actually calculate perpendicular distance between point and line. So px1 y1. So this is the formula d, ax1 plus by1 plus c upon root a square plus b square. What is the distance of a point 0, 0 from the line? So such type of questions are there. Find the distance of the point P25 from the line 3x plus 4y plus 14 is equal to 0. So we are given the point and equation of a line. We have to find the perpendicular distance between them. So solution, the distance of the point Px1 y1 from the line ax plus by plus is equal to 0 is given by P ax1 plus by1 plus c upon root a square plus b square. Here equation, in the given equation of a line, x and y replaced by x1 y1 and divided by square root of sum of squares of coefficient of x and y. The distance of the point P to 5 from the line 3x plus 4y plus 14 is given by P. Here A is 3, B is 4, C is 14. X1 and Y1 are replaced by 2, 5 and square root of A square plus B square, that is 3 square plus 4 square. So this is 3 into 2, 6 plus 14, 20 and 4 into 5, 20 plus 20, 40 divided by root 25, 9 plus 16, 25, root 25, 5. So 40 upon 5, it is 8. So this point is 8 units away from this line. Now find the distance between the parallel lines. So now first we see the formula. The distance between the parallel lines, ax plus by plus c1 is equal to 0 and ax plus by plus c2 is equal to 0 is given by P modulus of c1 minus c2 upon root a square plus b square. So this is the formula by which we can find the distance between two parallel lines. So we can see that here these two lines are parallel to each other because their slopes are equal, minus a upon b, and here also minus a upon b. They are just differing constant c1 and c2. So proof: to find the distance between parallel lines, take any one point on any one of these two lines and find its distance from the other line. हे बघा लाइन्स पॅरलल आहेत, त्यामुळे कुठलंही परपेंडिक्युलर डिस्टन्स कुठूनही टाकलं तरी ते सेमच असणार आहे. त्या पॅरलल लाइन्स मधलं डिस्टन्स सेमच असणार आहे. सो वी टेक द पॉइंट फ्रॉम वन ऑफ द लाइन. एका लाइन वरचा मी पॉइंट घेतलेला आहे मायनस सी बाय ए 0. ही लाइन बघा एक्स ऍक्सिसला जिथं इंटरसेक्ट होते तो पॉइंट काय आहे, मायनस सी बाय ए 0, minus c1 by a 0. So a minus c1 by a 0 is point on the first line. So this is the point on this first line. Now we can find this distance between this point and the second line. So its distance from the line ax plus by plus c2 is equal to 0 is given by P. So just replace x and y by, just replace here x and y by x1 and y1. What is x1? Here minus c by a and 0. So this is, so x replaced by x1, y replaced by y1, divided by root a square plus b square. So a gets cancelled, minus c1, b into 0, 0. So c2 minus c1. So minus c1 plus c2 divided by root a square plus b square. So this can be written as c1 minus c2 because modulus is there. So this is the formula. By using this formula, we can find the distance between two parallel lines. Now we see the example on parallel lines. Find the distance between parallel lines 6x plus 8y plus 20 is equal to 0 and 3x plus 4y plus 7 is equal to 0. So we write equation 3x plus 4y plus 7 is equal to 0 as 6x plus 8y plus 14 is equal to 0. We have to make the coefficient of x and y from both the equation same. We have to make the coefficient same. कारण आपण जे डेरिवेशन बघितलं ते सेम कोएफिशिएंट साठी बघितलं, त्यामुळे एक तर इथून 2 कॉमन घेणार किंवा ह्याला 2 ने मल्टिप्लाय करणार आणि कोएफिशिएंट सेम करणार दोन्ही लाइन्स. Now by using formula P c1 minus c2 upon root a square plus b square. So c1 c2 is 6 and 8 for both the lines. So here we get the distance between the given parallel lines, that is P. One of the constant 20 and the other constant is 14. So 20 minus 14, c1 minus c2 divided by root c square plus 8 square. So c square 36, 8 square 64, root 100, that is 6 by 10, 3 by 5 unit. So this is the distance between two parallel lines. Now, last point, family of lines. Consider the set of all lines passing through the origin. Equation of each of these lines is of the form y is equal to mx. So every equation has the form y is equal to mx if that line passes through the origin. So set of all lines passing through origin has the form y is equal to mx. Such set of lines is called family of lines. Here we got for different values of m, we will get the different lines. So these are the family of lines. ह्या सगळ्या लाईन्स आहेत त्यांना आपण फॅमिली ऑफ लाईन्स म्हणणार कारण ते एकाच पॉइंट मधून पास होतात ओरिजिन मधून. Consider the set of all lines which pass through the point a2 minus 3. So equation of each of these lines is of the form y minus y1 is equal to m into x minus x1. So y plus 3 is equal to mx minus 2. This set is also for a family of lines. So for different values of m, we will get different lines having each of these lines passing through the point a2 minus 3. The set of all lines which passes through a fixed point or which are parallel to each other is called a family of lines. बघा अशा सर्व लाईनचा सेट की जो एका फिक्स्ड पॉइंट मधून पास होतो किंवा एका फिक्स लाईनला पॅरलल आहेत किंवा एकमेकाला पॅरलल आहेत त्या सगळ्या लाईन्सना फॅमिली ऑफ लाईन्स म्हणतात. Now interpretation of u plus kv is equal to 0. Let u is equal to a1x plus b1y plus c1 is equal to 0, v is equal to a2x plus b2y plus c2 is equal to 0 be two lines. So equation u plus kv is equal to 0 represents a family of lines. So equation u plus kv represents family of lines, means it passes through the point of intersection of two lines or parallel to these lines u and v. बघा आता in equation u plus kv is equal to 0, put u a1x plus b1y plus c1 0 and v a2x plus b2y plus c2 is equal to 0. जर आपण u आणि v ह्या इक्वेशन रिप्लेस केलं तर काय मिळेल बघा, we get a1x plus b1y plus c1 plus k times a2x plus b2y plus c2 is equal to 0. जर आपण k न मल्टिप्लाय करून x कॉमन काढलं तर काय मिळेल इक्वेशन a1 plus k a2 times x b1 plus k times b2 into y and c1 plus k times c2 is equal to 0, which is a first degree equation in x and y, hence it represents a straight line. So we have shown here x u plus kv is a straight line. If lines u is equal to 0 and v is equal to 0 intersect each other in px1 y1, suppose the lines u is equal to 0 and v is equal to 0 intersect each other in px1 y1, then the coordinates of this point must satisfy both the equations. So here a1x1 plus b1y1 plus c1 is equal to 0 and a2x1 plus b2y1 plus c2 is equal to 0. ह्या दोन्ही लाईन्स या पॉइंट मधून पास होतात, इंटरसेक्ट होतात, म्हणून हा पॉइंट दोन्ही लाईन्स इक्वेशन सॅटिस्फाय करणार. Therefore a1x1 plus b1y1 plus c1 plus k times a2x1 plus b2y1 plus c2 is equal to, हे बघा x1 y1 या इक्वेशन मध्ये ठेवलेलं आहे. सो u plus kv या इक्वेशन मध्ये इथं x1 y1 ठेवलेलं आहे. So here as this expression is 0 from above relation and this second bracket is also 0, 0 plus k into 0, that is 0. Thus line u plus kv is equal to 0. Here we have shown that this line u plus kv passes through the point of intersection of lines u is equal to 0, v is equal to 0, because this line satisfies the equation of u plus kv satisfied by the points px1 y1. px1 y1 पॉइंट हे इक्वेशन सॅटिस्फाय करतो, म्हणून ही लाईन u प्लस kv लाईन या पॉइंट मधून पास होते. आता बघा सेकंड, इफ लाईन u is equal to 0 and v is equal to 0 parallel to each other, then their slope are same. So u लाईनचा स्लोप काय, मायनस कोएफिशिएंट ऑफ x अपॉन कोएफिशिएंट ऑफ y minus a upon b1 and minus a2 upon b2. Minus minus gets cancelled. We have the relation a1 upon b1, a2 upon b2. And so these are equal ratios. So this can be written as a1 plus k times a2, b1 plus k times b2. So each ratio is equal to a1 plus k times a2, b1 plus k times b2. तर हे आपण असं लिहू शकतो. So each ratio is a1 plus ka2 b1 plus kb2, slope of the line u plus kv. So this is the slope of the line u plus kv. u plus kv या लाईनचा स्लोप आहे बघा. मी स्लाइड पाठीपासून घेऊन दाखवतो. बघा u plus kv लाईनचा स्लोप आहे मायनस कोएफिशिएंट ऑफ x अपॉन कोएफिशिएंट ऑफ y. Minus minus gets cancelled. So this is the slope of the line u plus kv. Slopes of line u is equal to 0 and v is equal to 0 and u plus kv is 0 is the same. u plus kv line चा स्लोप हाच येतो, u is equal to 0 and v is equal to 0 चा स्लोप सुद्धा हाच येतो, कारण हे मायनस a1 अपॉन b1 आणि ही टर्म इक्वल आहेत. मायनस a2 अपॉन b2 and this term are equal. So line u plus kv is equal to 0 is parallel to lines u is equal to 0 and v is equal to 0. Now there is one example. Find the equation of line parallel to x-axis and passing through the point of intersection of lines x plus y minus 2 is equal to 0 and 4x plus 3y is equal to 10. We have to find the equation of line passing through the point of intersection of these two lines and parallel to x-axis. Since the required line passes through the point of intersection of lines x plus y minus 2 and 4x plus 3y minus 10 is equal to 0, its equation is of the form u plus kv is equal to 0. So every line which passes through the point of intersection of these two lines has the form u plus kv is equal to 0. So u is x plus y minus 2 plus k times 4x plus 3y minus 10 is equal to 0. So here 1 plus 4k times x, 1 plus 3k times y, minus 2 minus 10k. So this is the line. But we are given one condition, above line is parallel to x-axis. बघा एक कंडिशन ज्यादा दिलेलीच असते, त्या कंडिशनचा उपयोग करून आपल्याला k ची किंमत काढायची असते. So above line is parallel to x-axis. So slope of every line parallel to x-axis, slope of every line parallel to x-axis is 0. So slope of this line is 0. So slope minus coefficient of x upon coefficient of y is equal to 0. So when the ratio of two numbers is 0, if the numerator must be equal to 0, so 1 plus 4k is equal to 0. So k is equal to minus 1 by 4. So we have got the value of k. Now we put this value in this equation. So putting the value of k minus 1 by 4 in equation 1, we get, so x plus y minus 2 minus 1 by 4, 4x plus 3y minus 10 is equal to 0. So taking LCM, 4 times x plus y minus 2 minus 4x plus 3y minus 10 is equal to 0. So 4x plus 4y minus 8 minus 4x minus 3y plus 10 is equal to 0. So 4x here, this 4x plus 4x minus 4x gets cancelled. So here y plus 2 is equal to 0. So this is the line which passes through the point of intersection of these two lines and parallel to x-axis. This line is parallel to x-axis, which is required equation of the line. And आता हा शेवटचा पॉइंट आहे या टॉपिक मधला, an interesting property of a straight line. Consider any straight line in a plane. Suppose this is the straight line in a plane. It makes two parts of the points which are not on the line. तर प्लेनचे सर्व पॉइंट ही लाईन दोन भागात विभागते. Thus, the plane is divided into three parts. The points on the line, points on one side of the line, and points on the other side of the line. एक लाईन मुळे प्लेनचे तीन भाग होतात. एका साइडला असणारे पॉइंट, दुसऱ्या साइडला असणारे सर्व पॉइंट आणि लाईन वरचे पॉइंट. If the line is given by x plus by plus is equal to 0, then for all points x1 y1 on one side of the line, x plus b ax1 plus b1 by1 plus c greater than 0. समजा पॉइंट सगळ्या अशा पॉइंट एका साइडलाच असतील x1 y1, आणखी दुसरे पॉइंट असतील एकाच साइडला, तर ते सगळे पॉइंट जर लाईनच्या इक्वेशन मध्ये ठेवले तर ते ग्रेटर दॅन 0 असणार, पॉझिटिव्ह दाखवणार. And for all points x2 y2 on other side of the line ax2 प्लस by2 प्लस c लेस दॅन 0. समजा दुसरा पॉइंट दुसऱ्या साईडला आहे, तर जो तो पॉइंट त्या लाईनच्या इक्वेशन मध्ये ठेवला तर तो हा निगेटिव्ह दिसणार, निगेटिव्हच असणार. म्हणजे मला असं म्हणायचं आहे की जर पॉइंट एका साईडला असतील तर ते इक्वेशन मध्ये ठेवलं असता दोन्ही पॉझिटिव्ह असतील और दोन्ही निगेटिव्ह असतील, आणि अपोजिट साईडला असतील तर एक पॉझिटिव्ह एक निगेटिव्ह या टाइप मध्ये असणार. ठीक आहे. ते पॉइंट जर या लाईन मध्ये ठेवले तर एक पॉझिटिव्ह होईल एक निगेटिव्ह होईल, आणि एका साईडला असतील तर दोन्ही पॉझिटिव्ह और दोन्ही निगेटिव्ह. सो ओके, थँक्यू.